Hello, ladies and gentlemen. Welcome to today's session. We're going to be discussing Anova test in academic research. My name is Lucy Wanjiro. Welcome on board. So we begin by describing Anova. That is the analysis of variance. Yeah, Anova means analysis of variance. It is a statistical test used to analyze the differences among group means in a sample. Okay, it's particularly useful when comparing means across 3 or more groups. Anova assesses whether the means of these groups are statistically significantly different from each other. There are many types of Anova tests. And there are variations and extensions beyond this. The choice of Anova test depends on the specific research question, experimental design, and the characteristics of the data. Let's look at the various ways in which we can use the Anova test. Number one, we can use it in comparing 3 or more groups. We can use it in comparing the means of 3 or more groups. Anova is primarily used to compare means across multiple groups. It helps to determine if there are statistically significant differences among the means of 3 or more independent groups. For example, you might use Anova to compare the effectiveness of different teaching methods. Then we have experimental research. Anova is widely used in experimental research to analyze the effects of independent variables on a dependent variable. Researchers can also use Anova to determine if there are significant differences in outcomes among experimental conditions or treatments. It is very crucial in understanding the cause and effect of relationships. Then there is quality control and process improvement. In manufacturing and quality control, Anova can be used to assess the variability within and between different production processes. By comparing means across multiple groups, it helps identify factors that contribute to variations in product quality and performance. This information can then be used to improve processes and reduce defects. Then it can also be used for comparing multiple levels of factors. Anova is used for comparing the effects of categorical variables with multiple levels. For example, in a study comparing the effects of different doses of a drug on patient outcomes, Anova can determine if there are significant differences in outcomes among the different dose levels. Social and behavioral sciences. Anova is commonly used in social and behavioral sciences to analyze survey data and experimental designs. Researchers use Anova to compare means across different groups or conditions. That is how we use Anova. Then let's look at types of Anova tests. We have one-way Anova. This is the simplest form of Anova, and it is used when comparing the means of 3 or more independent groups on a single continuous dependent variable. For example, you might use one-way Anova to compare the mean test scores of students across different teaching methods. We have two-way Anova. It's also known as factorial Anova. This type involves 2 independent variables, that is factors, and 1 dependent variable. It examines the main effects of each independent variable as well as the interaction between them. For example, in a study examining the effects of both gender and treatment on test scores, gender and treatment would be the 2 factors. Then there is the repeated measures Anova. This type is used when the same participants are measured multiple times under different conditions. It's particularly useful for studying within subjects designs where each participant serves as their own control. For instance, in a study measuring blood pressure before and after treatment in the same individuals. Then there is mixed Anova. This combines aspects of both one-way Anova and repeated measures Anova. It is used when there are both between subject factors, that is, participants are in different groups, and within subject factors, participants are measured repeatedly. For example, comparing the effectiveness of different teaching methods between subject factors on students' performance over time, that is within subject factors. Then there is Anova, that is multivariate analysis of variance. This extends Anova to cases where there are multiple dependent variables. It allows you to test for differences in means across multiple dependent variables simultaneously. For instance, examining the effects of different diets on both weight loss and cholesterol levels. Let's look at how to use ANOVA tests. First, we look at the rationale. We have said that ANOVA is chosen when comparing the means of 3 or more groups to determine if there is a statistically significant difference among them. So let's look at the procedure. Number 1, define the groups to be compared. Number 2, check the assumptions, that is normality, homogeneity of variance, independence of observations. Then number 3, conduct the ANOVA test to calculate the F statistic. Then number 4, determine the significance level, that is the p-value. Number 5, if significant, perform the post hoc tests to identify which groups differ significantly from each other. And then number 6, interpret the results considering the overall significance and specific group differences. In an example, suppose you are investigating the effect of different types of exercise, that is aerobic, strength training, and flexibility on weight loss. ANOVA would be appropriate to determine if there is a significant difference in weight loss among 3 exercise groups. Let's break it down. What are these groups? The groups are aerobic, then there's strength training, and there's flexibility. What is the hypothesis? The hypothesis states that there is a significant difference in weight loss among the 3 exercise groups. The procedure is, number 1, you collect weight loss data for participants in each exercise group. Number 2, check the assumptions including normality, homogeneity of variances, and independence. Then number 3, perform a one-way ANOVA test using statistical software. Then let's say you've calculated the F value and it is 3.21 and the P value is 0.04. How are you going to interpret this? You're going to say there is a significant difference in weight loss among the 3 exercise groups at the 0.05 level, indicating that the type of exercise may influence weight loss. Ladies and gentlemen, we have come to the end of our academic journey today. Thank you so much for joining us. If you have found this video helpful, don't forget to subscribe for more insightful content. Also give us a thumbs up, like and share, and engage us in the comment section for reviews, questions, and suggestions. Until next time, happy researching. My name is Lucy Wanjiro. Adios.